recommend him for anyone who get a deeper understanding of analysis. His passion for making sense of complex data is evident in his very season, and the way he especially breaks down various complexity and intricate concepts of data analysis is, it's so wonderful. Throughout this series, I gained a valuable skill in data analysis, cleaning coding analysis, and data presentation using SPSS. And today we are very fortunate to have him in our mix. The speaker is the founder and director of Elite Research and Data Science Institute. He's a course coordinator for statistics for biomedical and health sciences at the College of Health Sciences, KNUST. He's also an R trainer as well for Ghana R user community. And he's currently a PhD student in molecular and cellular immunology at the University of Texas in Dallas. Mr. Ebenezer Senu is a highly accomplished data science educator and a research mentor with over 6 years of experience in biostatistics, clinical research, and biomedical data analysis. Without further ado, please we are not having an in-person meeting, but then with reaction, various emojis, let's welcome our speaker on board. Thank you so much.
Thank you, Godfred, for that great intro. I appreciate it. And to everyone, whether you are joining me for the first time or you joined us in some of our previous section, I welcome you once again to this section. And I hope by the end of today's section, we all have something to take, learn, or revise our knowledge on. So first, I'd like to start with some of the materials that we sent out there. And I'm going to share my screen. Also, I want you to take note that today's training is more practical. You are just going to dive and understand. And I'll make my possible best for us to look at the basics because the heading is everything should be simple as ABCD. So we are looking at simple things today. So you don't have to be worried, whether it's your first time or you have some level of experience. So we sent this link out there, okay? The link, okay, you are now about, I want to be sure you're able to see my screen first. I'm sure you can see now. Okay, so we sent out this link, right? And the link contains, okay, you can now see my screen. So the link contains some of the materials we are going to use today. So this is a paper that we are going to use as a case study today. And the paper comes with the data in the SPSS, also in Excel. And also it has a folder that you can download the SPSS. This is for Windows. Okay, so if you're using Mac, probably I'll have to send you a Mac version later on. So this for Windows and also the R software that we used tomorrow. Can the link be shared? Yes, I think George, they will resend the links in the chat again. They'll resend the link to the chat again. Also, before that, if you have any question, just put it in the chat or you can just unmute and you talk. It's more practical, like it's not a lecture. Okay, so let's enjoy the session today. Okay, so let me also start by my PowerPoint. For that, let me close this. I just want to give you a brief background here. Then we now also zoom back. Okay. I want to confirm you can see from my screen and also hear me clearly so that I could adjust if possible.
Yes, please.
Yes, please.
Okay.
Yes, Ebenezer, we can hear you and we can also see everything on your screen.
Okay, great. So today's session has been, let's say, come to fruitful. So far as we've started, it's already fruitful, so you don't have to be worried. Because of the Federation of Ghana Medical Students Association. So thank you to Godfred for bringing us together. And myself, I'm going to take you for today. I'm the founder of Elite and Axia said. And George will take you tomorrow for R. George is a wonderful person and he's also part of us, the Elite Research and Data Science Institute. So he will be taking more on R tomorrow. So I do more viral stuffs for now. And I want to introduce our institute to you once again, that we do a lot of wonderful stuffs. So these are some of the visuals you can see about us. Just try and follow us on the social media pages so that you keep updated on anything that we do. And we are just basically going to focus on 2 or 3 things. Microsoft package, because we cannot go into data analysis without the Microsoft packages. Then today I will take you through the SPSS. Then R will be tomorrow. So that is just the outline, and that is the only PowerPoint I'm going to present to you today. So now let's come back to understand some basic stuffs. Then we can now move on into what we are going to analyze. So before data analysis, before you can even think of, you want to analyze data in SPSS, in R, you should have information. You should ask us, what are you going to analyze? You cannot just then I will say, well, we are going to analyze data, or we should have your research topic. We should have the objectives. So we should have a lot of information that will tell us what we are going to analyze. If not, anyone will just stand up, click, and produce anything, but that will not be called a result in science. So today's case study we are going to use to look at how we can analyze some of these things is a paper we published in Nature Scientific Reports about vitamin D. The paper has 2 parts, vitamin D and total antioxidant capacity. So I'm sure today most of us are medical students, so you better understand these stuff. But we are going to focus on vitamin D. Okay, we are going to focus more on vitamin D today. So I'm going to give you some background. Then we can now go to the data that we collected. Then we can now do some analysis on it. So we know vitamin D is one very important nutrient that we require in our body, and it has different function. Okay. So what's the basics is that this vitamin D, generally, especially in Ghana, a lot of people has a low vitamin D level. And if you read more into papers, they saw that among women that even undergo a lot of those that are requesting to record, I'm doing the recording here, so you don't have to be requesting to record. Okay, after that, the recordings will be shared out. Thank you. Yeah, so if you do a lot of research, you see that there's low level of vitamin D in Ghana. In fact, one of my professor back in K University, Professor Samoset, he said one paper that he published, if you read about it, he said that there's high sunshine in Ghana. You know, we believe that vitamin D is the sunshine nutrients. Okay, but in Africa or Ghana, you see that we have a lot of sunshine, but why are we having a lot of vitamin D deficiency? So generally, there's a lot of people that has low vitamin D deficiency, and it leads to a lot of other implications. So that is the background of this paper. So, but there's no any standard way for us to reduce these measures, because especially among women, it can lead to adverse maternal and neonatal outcomes. So they can give birth to deformed babies and the rest. So that is the problem. Every research has a problem. So that is a problem that we identify. Then we now ask ourselves, can we do something to now reduce this vitamin D deficiency level? So what we did is we recruited pregnant women in their first trimester, okay? Then we gave them some fortified vitamin D probiotics. So they were taking those probiotics. Then we followed them up to 6 months and we took their samples also. Then we were able to gather the data. So that is just the basic understanding of today's paper. So in detail, we're supposed to know what is the study design that we use. So this is more of a single-blinded controlled trial. So from our study design class or research method, we're able to understand that most often there are two main study design, the observational study design and the experimental study design. So this is more of experimental study design. When we talk about experimental study design, we are talking about the community trials, the field trials. Because here we are going to give some group treatment. So it falls trials. But in most of our study, we do the cross-sectional studies, the case control studies, any of the cohort study, they fall under the observational studies. So this is one of the real experimental studies, which is a single-blinded control trial that was conducted in Ghana, specifically in Asante region. So we recruited the population, okay? We recruited the population, and this population were 18 years and above in the first trimester of attending antenatal care. So this participant, how we able to identify the number of people that to be recruited were all calculated. So that make the scientific research. You need to calculate all those things. If we talk about the observational studies like the cross-sectional studies where we can talk about the Cochrane formula, the Yamani formula, or the case control study where we can talk about N-Cassell's formula. So each of the study design that you are doing depends on how you calculate even this sample size. So we're able to come up with some sample formula. This into details. Then we're able to sample them, and generally from baseline, okay? We need to understand all this in order to handle data properly. Because if you are doing analysis, you need to understand the work. That will inform the kind of analysis you are going to do, or how you are going to analyze or handle or present your work. So someone that's doing this cross-sectional is there, right from presentation is not the same as someone doing case control. So that's why we need to understand the data, the science behind it. Then we're able to analyze the data towards it. So what is happening here? So first, we access the women, then we took baseline data of 126 people. Okay, so in baseline, we took a lot of information from social demographic to clinical. We access their knowledge. So if we go down to the paper, we see all those analysis. We took even the kind of food that they take and all those things. So those are baseline. So that one, we just sample them. There's no any treatment. So it means that we can even do analysis on only the baseline data, which they were all pregnant women attending the antenatal clinic in the first trimester. That is your first set of data. So it means that a lot of people that does research, that only recruit people once, it means you only have that data to do analysis on. So we can do a lot of analysis on even the baseline data. So after the baseline data, they now allocated into what? Two groups, 63, 63, where some of them receive what? The treatment. Some of them did not receive the treatment. Then we followed them up 6 months. Then we also took another sample. So in this case, I don't know what will be the main variable of interest as we are following them up at the end line. What do you think will be the main parameter of interest after 6 months? You can put it in the chat or you can speak up from the story we are running so far.
Okay, I think that, sorry, I think
Okay.
that you are trying to see whether those who receive the intervention, you are comparing two groups, those who receive the intervention and those who did not receive the intervention. What will be the results? That's what I think. So those who have received the vitamin D fortified probiotic yogurt, and that's the control group. The control group, they didn't receive the vitamin D fortified probiotic yogurt, but the interventional group, they received the vitamin D probiotic yogurt. So you are doing follow up after 6 months to see what is the result of the intervention, whether truly, if you receive the intervention, you would actually be well or not. And those who did not receive the intervention, what happened to them at the end? Yeah.
Great, great. Thank you, Akosia. As I said, today's session is going to be more interesting. So with this great input from Akosia, we are really moving in the right direction. So we need more input as we move. Yes, so exactly. So one, we are going to see that whether even the vitamin D levels, because baseline, the assumption is that, and we will go into the data right now, you see that at baseline, generally the deficiency level will be low. Then endline, it is expected that those that will receive it will have one, improved vitamin D levels, and two, there will be lesser adverse effects. So this paper is going to publish in different stages. Some of the publication will come out and you see that some even other aspect, like some of the adverse effect has reduced. So as soon as you understand like what you are doing like this, yes. So thank you also, Gladys. There should be significant increase in vitamin D levels among those who receive vitamin D. Yes, great. Yes. So as soon as you understand your design, your study, like what it means, then you able to what? Now come back to what? The data analysis. So even if you are analyzing data for someone, when the person send you data, the person has to sit you down, or you need to have meeting with the person. The person will explain his or her work to you, telling you that this is what I did and the rest. Then we're able to produce results towards it. So that is the basic things. So let's look at some of the results that we produce in the paper. Then we now go back to do the analysis like that. So this is just basically the baseline. So baseline descriptives of the 126 participants, because this one, now we've not have any treatment. So the facilities that we recruited people, their ages, educational level, employment status, and the rest. So from the questionnaire, we took all these parameters from the participants. So the first part of the analysis, we want to look at what is our baseline, the general population, how are they look like? And why are we seeing some of them are frequencies and percentage, some of them are mean standard deviation? Yeah, so most often if you join our extensive classes, we will take you from the basic to advanced, where we even teach you how to look at any kind of data. But the bottom idea is that the kind of variable we have will inform us the kind of analysis we are going to do. So we are going to see that also today. So broadly, there are two kind of variables that we handle. What we call the categorical variables and what we call continuous variables. But if you move from the peak, we have what we call variables, then we move to numerical variables. And the numerical variables, we can have what we call discrete variables, and we can have what we call continuous variables. Discrete variables are only whole numbers. But continuous variables can have what? Whole numbers and decimals. So we classify any number that comes with numbers as continuous variable. That's the term that we use in statistics. So if you read a lot of either papers, literatures, books, those are the new terms. So anything that comes with only numbers like age, 20 years, 25 years, all those things, they are called what? Continuous variables, broadly, to represent all of them. If you go to typical statistics class, they'll be telling you ratio and all those, but as soon as it's come with numbers, here we classify them as such. Then we have those that will come in groups, like age itself can be also be in groups, okay? So we have age that has been what? Retransformed or recoded into groups, okay? And today I will want to also remind you that some variables, when we are creating groups, we are focused on the distribution of the participants, not the interval. So for example, you see this age group, 18 to 25, 26 to 30, 31 to 35, then 36 to 45. So you could see that the intervals are not the same. Like some will be creating group like 5 intervals. Now, in statistics or data analysis, our interest is more on the distribution. Because if you are focusing more on the interval, like going to create a group of 5 intervals, 10 intervals, it can affect your statistical levels. So we focus more on the participant distribution to create some variables. This is an exception to standard classification like BMI. BMI come with a standard cutoff point, like you want to classify them into normal, underweight, overweight, obese. That one will go by the cutoff point. Okay. So any variables that will come with what? A categorical or groups like educational level, primary, junior high, senior high, tertiary. Those descriptive analysis we do on them are frequencies and what? Percentages. So I'm going to analyze some of those stuffs to you, but you have to understand, as soon as you understand this concept, then you're able to analyze your data simply and present your results to your supervisor and you're good to go. So you could see that all categorical variables are just limited groups. They have limited groups. You present them frequencies and percentages. So throughout, so that's the presentation in this baseline that we have. Then some of them that come with continuous variable, like age in years. Those ones, we further do what we call normality tests. But today we are not going to details. I'm just explaining to you, and we are going to do some of the analysis to you. We present that, so this one is mean standard deviation because it's a continuous variables. So those are some of the analysis that we proceeded. I told you we also asked them some dietary pattern. We asked them the kind of food that they be eating, like that. Then they answered them their food pattern supplement. Then we further did classification. So from this question, we're able to what? Further divide them into adequate dietary pattern and inadequate dietary pattern. So this kind of analysis is similar to people that do those CAPE kind of study, like the knowledge, awareness, practice, attitude, those kind of study. So let's say you've asked participants about their knowledge level on vitamin D. So at this stage, when you are doing the analysis, you are going to first do basic analysis on the presentations, on the responses that they answered from the question. They're able to see that, 50 know that they know about vitamin D, this does not know. Like you have about 10 questions on knowledge on vitamin D. So after you presented that, another way is to further score it. It's like you've given your student exams, okay? Then after that, you mark them. Then after that, you score the whole class. Then you give them a cutoff point into A, B, C. So the knowledge question or attitude question or practice question that we mostly do. After that, we sum up all the scores, then we rank them. Then we give a cutoff point. Then we can say that those that will score 70 and above, they have, let's say, adequate knowledge. Or in this case, we use a cutoff point. We've described this in the methodology. Then we said that, oh, these people take a good, they have adequate dietary pattern. Or you will say they have adequate knowledge on vitamin D. Or and the rest that fall below the cutoff point, they have inadequate. So we did all this. Then we also look at sunlight exposure. Then we came out with this analysis. So at the end, this is still a baseline. So you could see that truly at baseline, we saw that, oh, a lot of people have vitamin D deficiency, okay? Then, so today I'm not going to talk about TAC, we are only talking about vitamin D aspects. Then we proceeded to do a lot of analysis. Then we give them those supplements, we further what? Look at the end line, how it improves and the rest. This is called also a PET where we look at the trend from the baseline to the end line among fortified and non-fortified. You saw all this trend. So we are going to replicate some of this process. So that's the understanding of the paper. Let's come back to the data. Before that, any question? To see if we have understanding of the work, then we now have a data. Then we say, how do we handle the data? How do we do some of the analysis? If you're with me, put one in the chat. I want to make sure we are all together on the road. Yes, yes. Great. Good. Okay. Yes, great. We are all following and enjoying the flow. Okay. So if you're able to, great. If you're able to, I think, let me see, is there a question? So how do you know what to do with the data? Yes, so we are now coming to the data. So first, as I said, you need to now understand the research. Then you now what? Take the data, then you come back. So how do you categorize? So now let's come back to the data. Okay, so when you have those things there, you'll be able to do some of those things. So first, I want to also understand that everything starts from Excel. We enter data into Excel. Excel is more of the universal recipient of what? Data. So if you gather all those data, the first place is either you're using the online platform like the Red Card, Google Scholar. By the end, you still extract them into Excel, okay? Then within the Excel, you can do what we call data cleaning and coding. Coding is for when we are going to analyze data in what? SPSS. So for example, age. Okay, age. If you want to further create an age group, so what Ransom just said. So because age group, if you want to create more age group, then you can say that, oh, you want to create age group of 26 to 30 years. So for example, you just filter. Yes, Brian.
Oh, hi. Thank you for the opportunity. So just a quick question. Since you're talking about the age, I want to find out what's the rationale behind the age groupings. Because you mentioned that you want to have distribution in your data. So is there like a backing, more or less like a standard that you are using to group the age? Like what's the rationale between grouping them from 26 to 30 and then 31 to 35? Yeah.
Great. Yes. So as I said, apart from the case that you are very interested in particular age group in your study, but age as a variable, apart from other variable like, let's say BMI that has a particular cutoff that you are supposed to use to create your groups. age, it's recommended that when you go take their actual age. So a lot of people, even when they are designing questionnaire, they already put those age there for people to take, assuming that a lot of people feel uncomfortable giving their age. But it's good they give their approximate age so that you take their raw ages. Then when you come, you look at the distribution. So the reason why we are more interested in the distribution compared to the equal interval is if you create 20 to 29 years, 30 to 39 years, then you end up having, let's say, 100 people, 20 to 29 years, and let's say 5 people in 30 to 39 years. That one, you not get any statistical significance. It's going to affect the statistical analysis. So you do analysis like you are comparing a whole 100 people to 5 or to 0. Some groups will have single numbers. So in this case, so the basic concept is that it affects the statistical output or statistical significant levels. So instead of you to getting a good p-value or good confidence intervals, it will give you a very weird confidence interval. So that's the basic idea, that we don't pay attention to the interval, but to the distribution first. So if you think that they have a good distribution before you focus on the interval. I'm sure we should be on the same level now, Brian.
Yeah, thank you.
Okay, great, welcome.
Please, I want clarification.
Okay.
Sorry. Please, which of the data sets are we using? Sorry.
Okay, so in the drive, there are two. This one. Download both the Excel and the SPSS format. Because I will just show you how to import the Excel also into SPSS to use. That's why I sent the Excel also. So download both. But now let's look through the Excel data too. Then we can now move to the SPSS. So I'm currently on the Excel file. Okay. Then Excel file, there's sheet 1 and another one clean coded. And again, because we are only doing practice, a lot of variables in the published paper have removed them. So I've just left with few of them for us to do practice on. Like we just want to do some analysis on to better handle the data from Excel to SPSS. So first, I just want to just touch on what AMSA also asks, how do we create the groups? So after you've determined the kind of groups to create, okay, this is applicable to any variable you want to create, both continuous and categorical. Before that, let me retouch on the kind of variable, because the kind of variable we have inform the statistical analysis. So within any data, you always see two variables where we have what? The continuous variable like age. You see, they all come with different numbers. Then we have what? Some of them that come with alphabets. Most of them are what? The categorical variables, like educational level, your nationality. But some of the continuous variable can also what? Be transformed into what? Categorical variables, so that we can handle them. Like age, we can do analysis on age itself and also age as a group. Yeah. So I'm just going to show how to create age group here. Then we can now move further to also understand other variables. So if you are convinced that you want to create a particular group, so for example, this paper, the age groups that we created were, so I'm just going to 18 towards 25 years. So if you are convinced that you want to create these age groups, so how do you do that? This I'm doing in Excel. It's very easy to do these stuff in Excel. But we can also do all these things in SPSS. We can do this in R. But why are we preparing all this in Excel? Because it's very easy to do these things in Excel. So some of the styles, we can do them easily in Excel. So it's better we do all those things. The data is well clean. Then we now what? Import the clean and coded data into the statistical software. In fact, a lot of people also still do some analysis in Excel. Like there's analysis that we still do like using the Excel stat. So Excel has another form called Excel stat where we do some advanced analysis. So you will still be meeting Excel everywhere you go. So Excel helps to do a lot of stuff easy. Some stuff can be done easily. Then we can now move them into the statistical software. So the first one is 18 to what? 25 years. So you just highlight that column. Okay, you highlight like this. If we just put the cursor somewhere and the filter is going to bring the filter to all the drop down. But I'll filter, I'm just interested in each. Then I'll filter. Sometimes some people want to, but in data analysis, you don't have the time to move cursor to this sort and filter button. You just have to use the shortcut. So I'll filter the each column. Then I say Control Shift L. It will bring the drop down. The drop down here. Then you click on it. Then you're able to see all the data inside of this variable. Then it's sometimes you see a lot of very long inputs. Then it's very easy to use the advanced filters called the number filters. If the variable has only numbers, the number filters will be available for you to use. Then we can use any of the conditional filtering to select the groups. So for example, in Excel, between means it includes the boundaries. Maybe someone could say that the normal English between means between A and let's say C, it means it's B, it's only B. But Excel, if you say between A and C, it includes A and C. So sometimes the software you are using also differ in the kind of terms or the meaning of the terms that we are using. Yes, yes. So most often we teach people how to input data in SPSS, but it's not advisable to do that. You have to input your data in what? In Excel. Because if you input your data, for example, it will also affect some analysis. Because if you go and input educational level at tertiary, those things, alphabet, some analysis you can do. Because Excel, for example, is easy to manage data with numbers. Okay, so it's good you have to always enter your data in Excel first, clean well, code it before we import it into SPSS. So although we always teach people how to input data, but we don't do that. You have to input all your data in Excel first. Then we now move into any statistical software that you want to use. Yes. So age number filters. Then between, because this, sorry, we have the phase boundaries. Okay, the phase boundaries. Let me see. Yeah. Yes, yes. Any online platform like Redcap, all those things. I've not, so the matter is I've not used the Info client before, but if it works like the similar online platform, that Redcaps, all those things, at the end you still extract those data back to Excel. Okay. If it's an, I don't know, Tamara, is that an online platform? Yes, okay. So all the online platform, at the end, there's no way you import data straight from online into a statistical software. You still download those data and it will come as CSV file or Excel file, which is similar to Excel. And it will be ready in Excel before you now move to SPSS. Okay. So that's how those data works. So at the end, you still land yourself in CSV file or Excel file. You need to bring the data from online to your PC before you use it, and you are good to go. Yeah. Okay, so we are just trying to create this group, then we move to the next one. So we have, you just input 18, then equal to 25. Yeah. Yeah, SL version 21 is fine. Yeah, it's good. Yeah, I think myself, I'm still using the 2021 too. Yeah, it's good. I'm unable to get the shortcut. Control Shift. Oh, no, it works. So if it's not working, it means that it's either this, you are scrolled down. Make sure, don't scroll down. If you scroll down, you can't see the drop down. Make sure you are at the first row, okay, row 2. Or you can see your headers. Then click on the variable, then Control Shift and L. You see the drop down coming and going. Yeah, it works. It will work. And before that, when you download the data, okay, from online, you should enable editing. If you've not done that, close the whole Excel again and relaunch it. You see this kind of notice they are giving me on my Excel. You see it enable editing. Okay, you see enable editing here. Then you click on enable editing. Then you can now have command over your data set. Let me know if it works now. Osmani. Along the way, if you have any challenge, you can equally share your screen too, although we have limited times. But sometimes people will really learn from what someone else is also doing. Let me know if it works or you're able to share your screen. Then we can help you out. So, okay, so I'm going to proceed. If you, sorry, if you have further challenges, just let me know. Then I'll able to sort you out, and you're good to go. So I'm just going to quickly create this. Then we are good to go. So I'm going to use between. Then I said 18 to 25. Then I said okay. Okay, then I'll assign one. So this is the groups. So I create groups. So I want to code all those things one. Okay. I'll assign one here. Then the next age group. So any grouping that you do, you have to take notes. In fact, what some people also do is that on their questionnaire, they will code all those numbers that they've been taught from class. Then they input the numbers in the Excel or in SPSS. We don't do that. When we are entering data, you have to enter your raw data because cleaning coding is part of the analysis. So during the analysis, we're able to inspect whether there's any typo error because female, male, if someone is inputting that and the person makes a mistake, instead of FEMALE, a person spell FMALE, be able to correct all those things and make any needed input before we proceed to analysis. It's better to spend months doing data analysis than to rush and give a wrong statistical result to someone. So the analysis comes with a lot of things before the actual analysis. Yes. Yes. So for this data, because we've already created the groups, we considered, hold on a minute, let me get water. Yes. Yes, you have to always consider your minimum and your maximum, okay? In fact, because this is a published data, already we knew the minimum and the maximum. That's why we're able to create from the minimum 18 to 25, and also the maximum 36 to the 45. So you always consider that. Good. Mhm. Yes, so I'm going to finish up with the grouping so that you know that. Okay, how you arrive at one? Yes. So I'm going to do that. So the basic understanding is that SPSS, okay, this SPSS, as I said, is empty. I've not imported the data here yet. But SPSS is able to handle data in 1, 2, 1, 2. So even this educational level, you can import tertiary junior high into SPSS. We have to first create groups or convert all of them to numbers, okay? So you will specify your code. So those are some of the side things we do. You will not see them in the results. But during the data analysis, we do all those things. So we want to create groups such that, so let me copy these groups. Let me even launch my notepad so that you better understand. Okay. I'm going to a new window. Okay. So although we are creating age group, okay, what we are saying is that the age group we are creating, we want to create age group of 18 to 25 years. Then the next one, 26 to 30. So a lot of people, everyone that has gathered data always take age. So that's why I'm spending some time on age so that I can apply it to other variables. 31 to 35. 31 to 35. Then we said 36 to 45. This is the ages that we had and the groups. So this is what you see in the published paper. But how do we handle it to analyze in SPSS? In SPSS, you are not going to see this in the input or the data itself. You only see it as a value labels. So in this case, we are going to code this 1. So a lot of people that's going to start class, they will be teaching you this. And people will do this on their questionnaire. But we do this during analysis. So we are going to say that those that are 18 to 25, we want to code them 1. In fact, the term coding is different from the coding they are going to do in R. Okay, this also at SPSS, we still refer them as coding. So change the 6 to 30 to 31 to 35, 3, 36 to 45, 4. In fact, let me launch. So I'm going to launch my data in SPSS. So I sent you another data in SPSS so that you better understand that. So if you launch the SPSS data, so I'm going to open that. Okay. So that you further understand that. Then we come back. So this is the SPSS data I sent you, and this is what we are going to use. But before that, we are trying to understand how did we get here? Because I've just coded everything and sent you SPSS data. How did we get here? Before we use it for analysis, is to code it. So if you look at the value labels, this one, you only see this is the actual coded data. You see only ones throughout. You see, you don't see any alphabet in this data. At the end, SPS data is supposed to look like this. Everything's supposed to be hot in numbers. But although in numbers, there are some that are hot, continuous variables, and some are hot categorical. Then here we further values. That's why when I click the switch between the value labels, it gives you how we've also what label it. So I'm going to show you that all those things. So it means that for the age group, for us to what from age to the age group, we need to what code them into 1, 2, 3, by telling them that all those that are between 18 to 25, we want to give all of them what 1. Then the next one will filter all those that are what 26 to 30. We want to group all of them as what 2. So you filter all those things. Then we assign them because we want to maintain the continuous variable and also create a categorical. That's why I'm assigning the new categorical in a different columns. I'm not replacing it. Then you filter like that. And again, the person that also asks about the minimum, because we know the minimum and the maximum, that's why we are using the between. If not, you can also use any of the conditions, less than or equal to. If you don't know the minimum, you want to group all those that fall below a particular cutoff point, you can use that. So any of the conditional filtering, you can use that. Then the next one, we want to do what? 31 to 35, 31 to 35. Okay. Then you code all those things, 3, like that. Then the next one, so for example, greater than or equal to 30, 35. We can say greater than or equal to 35 for the last group. So that's what we did to get that. Then the same thing, the educational level, that one we created them, we recoded them. So for example, from primary, we can replace all of them with 1. So for these coding numbers, it depends. You can choose any number. You can say 1, 2, 3, like that. Junior high, you replace them with 2. So this is how we code categorical variables. Because at the end, SPSS is able to handle data in numbers. So even all categorical variables have to be recoded into what numbers before they'll be used in the what analysis. So this will be 3. Then the last one, is 4. 4. So you do this. So if we now move to clean coded, that's how we came by all these variables. Okay, all these variables. So that's the information we get it. So let's also try to understand. So in this data, I've removed a lot of information from the published paper so that we can just use these few variables to practice. We have age, we have educational level, number of previous pregnancy, the household, number of children, their nationality, the dietary pattern. We only have the squad here. Then this is the baseline. So let's see. You could see that I just touched on what? Age. But let's say baseline vitamin D. So this one we measured, we took their blood samples, right? And we measured the 25 OD vitamin D to determine the vitamin D levels. So these variables were gotten from ELISA. But at the end, we need to now use continuous variable to now group them into deficiency and what non-deficiency. So how do we do that? So this one, you don't wake up and say distribution or you are using your own cutoff point. So this, we go back to WHO cutoff point. What does WHO say? If you have vitamin D level of this, then what do you fall? So this kind of grouping depend on what? A standards or cutoff point. So WHO, so if you look at the paper, we've indicate all these things. So everything that you do, you have to specify in your paper. That will help you publish in high impact journal. So you could see that according to WHO, so this is what we measured in what? Using the ELISA. But WHO said that those that will fall between 20 nanogram per ml, we should classify them as deficient. Those that have more than this should not deficient. Sometimes you read from other papers, they will be even intermediate, but this is what we use. This is the cutoff we use, and we reference the source. So this paper 18 also reference how to do cutoff points. So that is how we came by this grouping. Then at the end, from the measured what? Continuous variable, you'll be able to create what? A categorical variable to see that, oh, those that have deficient or not deficient, the same grouping like that, the same N line. So at N line, to be able to specify that. So that's how we come up with these groupings. Then you have a good data for analysis. Let me see questions. Yeah, so we are saying that, yes. So again, that assumption is everywhere, but we are saying that a variable like age grouping, okay, we don't depend on equal interval. So after today's section, everyone has to decode that assumption that everyone has that issue, equal interval, 20 to 29, 30 to 39. Apart from for the study that you are doing, have a particular interest in a particular group. Like you want to even see weeks, you want to focus on first trimester, second trimester, there's a particular literature around it. But most continuous variable that we randomly classify, we are more interested in the distribution so that we can easily compare the distribution. But if your study is very interested and you want to see this age group, then you have to still maintain the age groups. But random classification of continuous variable into categorical, we are interested in what? The distribution. If you see there's distribution throughout before we come back to the intervals. So the interval is not a priority, okay? That's the basic line. And you see this in the analytical output. Can you code the categorical variable with 0? Yes. So one thing that we mostly do is that you can also start from 0, 1, 2. Or yes or no responses. So if you look at most of our analysis that we do, any yes or no response, if we say no, 0, yes, 1, or negative, positive results. Mostly we do negatives for 0, positive for 1. Okay, so you see that in codings that we do. So you can include coding, and you are right. Yeah. We should be able to be on the same level. Yeah. So if we're able to create all these variables, so some of these parameters like vitamin D classification categorical, you need to go back. So you could see that here we are not dependent on equal intervals. We are dependent on what is the WHO cutoff for us to group you into this. Then you now create all those groups. Another example is BMI. People will go to the field. You just have to take your height and the weight. Then you come back and come and what? You come back and come and create all those groupings. Okay, come back and create all those groupings and you are good to go. Any other question? Okay, then we are good to go. So if we're able to understand all these basic stuffs about data, then your data is now become ready for analysis. So that's why I've said that analysis is not just like you get the data. I can show you all the click stuffs to analyze right now, but what are you analyzing is very important. Then your data will become ready and import. So the next thing I'm going to show you is how do we now bring the data into what? SPSS. So to do that, so let me even be on there. To do that, today I first sent you, if you just click on the SPSS data to take you to SPSS if you have SPSS. But if you don't have it, you open your SPSS. Sometimes there will be two windows that opens. You can always close the first one. Then you now be at the interface. Before that, I want to also tell you that if you are first time you are seeing SPSS, SPSS has two windows, what we call the input window and the output window. The output window is here. When we do any analysis, you see the result will come to the output window. And the input window is where you see your data. Now, within the input window, we also have two views. We have what we call the data view and the variable view. The data view, you're able to see all your data that you've inputted. But you come to the variable view, you're able to see the variables and the characteristics about the variables. What can we say about the variables? But before that, let's import data first. So if you get to know how to import data, then we now come to see some information to know about the variables from SPSS. Let me see whether we have. Yes, okay, Juliana, I'll go over. Yeah, the age grouping again. Okay. Oh, anytime I create the age group, okay. Okay, so let me first deal with the last person. How do you get the file? So we sent a link. Okay, we sent a link. We sent a link. So I think they've also put the link in the chat. Then it will take you to the drive. So every material I'm using is on the Google Drive. And anytime, even after the training, you can still access it while the recording and follow and practice. So in the Excel, I have the Excel data file, SPSS data file, and the paper that we are using as a case study today. Then there's another folder that has the SPSS. Then another folder has the R and R studio you are going to use tomorrow. Because at the end, I'm going to show you why we have to now move from SPSS to other statistical software like R. So that will zoom you into the R software tomorrow with George. Okay. So let me come back to some people still want to create the age groups. Okay, someone will post the link again. So they'll post the link in the chat. So let's deal with the age group. So as I said, creating of grouping like vitamin D is the same thing. You filter, then you assign. So let me come back because you should be able to do this. That will applicable to any grouping that you're doing. So for example, if you filter, okay, age group, you see the drop down. You see the drop down. As I said, I can do all these things also in SPS, but SPSS is very complex. So you should be able to do this easily. SPSS is complex, it has a lot of process, but here is just two things. You filter and also assign. So you bring down the number filter. I don't know, those having challenge, can you share your screen? I don't know. Can any of you share the screen? Maybe that would be better. If you have a challenge, you want to share your screen, let me know. Yes, find and replace. You can use find and replace, but find and replace is for no, at this stage, I don't teach you how to use the find replace. There's a different way that we use the find and replace. The find and replace is very recommended. Let's say we have about 10 variables. All of them has yes or no. That case, for me, I'll just select the whole 10 variables. What I'll do is that, okay, Edu, a minute, I'm going to allow you to share. So for example, let's say 3 variables that they are all yes or no. I'll filter all those things, find and replace. So no, 0, 1, yes. But if you are not sure about that, you make errors. So that's why mostly from these basic things, I don't take you a lot of shortcuts. So here, there's different shortcuts to a lot of stuff. So for example, this age group, we can't use find and replace here. So you can use find and replace for the alphabet, the categorical variables. Then you are good to go. Let me see. I'm going to stop sharing my screen. Let me see what. Yes. So Edu, share your screen. Let me see what you are doing, the challenges you are facing now. Okay. So yeah, we can see from your browser. So go to your desktop, open your. Okay.
Please can you hear me?
Yes, yes.
Okay, so I've created the filter already.
Yes. So click on it. Then go to numbers filter. 18.
So I'm creating the age range for the first one.
Yes, 18 to 25.
And then I'll come here and click one.
Yes. So put 1 there and you drag to cover. No. Okay. Yeah.
So my problem is the next one. When I come to the number,
yes.
the number filter, and I come to between.
Mm.
So I'll 26 to 30.
Mm-hmm.
Then I'll click OK.
Then you put 2 there.
Okay, sure.
Yes. So all the people you filter now are now within that age group.
Okay.
And also this approach sometimes can give you the approach that you just put the cursor there, you double click to cover. Sometimes it does not cover some of the participants. So that's why you make sure that you click and drag it to the last. So drag it. So click, hold on it and drag it to the last.
And now
Great. Then you are sure that you cover every participant. Any error you make is going to affect your statistical analysis. So you want to ensure a very high accuracy in everything. You are ensuring that everyone is assigned the right thing. So you now filter the next person, 31 to 35. So anyone
Have
else
to
that
even
also have
call
a
them and repeat
challenge?
them. Yes, Charles.
Thank you, sir. I get it now.
So now, yeah, do for the
I
everything.
want
Do
to
for
leave the
everything.
Zoom.
The last group. Okay, let's see. 36 to 45. I think it was 45.
Okay.
So you have to do for the last group is 36 to 45. Yeah, shortcut is Control Shift L. Okay. So some people too, when they get here, they said they are only seeing one group. You could see that at this stage, you're only seeing this group because we filter that. So at the end, when we are done, you want to now see the whole data. You have to defilter. So how do you put the filter off? The same thing, Control Shift L. So just click on the whole thing, that column, and just click Control Shift L again. Then the whole data comes. So if you scroll down, you will see that you've assigned all the codes. So scroll down your data. You see that every participant has taken out a code. Then you are done creating the groups.
Thank you, sir.
I don't know if anyone else has any challenge at this stage. So this will really, yeah. So when you're done, you can stop sharing your screen. Yes. Let me see in the chat. Okay. So anyone else having any challenge? Then we are good at this stage. So at any time we can go back and yes, practice on your own and you are good to go. Okay. Great, great. Everything is very simple, right? So we are making things simple. Everything is simple. Everything we are learning in class is simple, but it's how we approach it. But we will be fine. So I'm going to share my screen back again. So I presume we are all done. So although I sent you the SPSS file, when you open, it's just to make the training easy for us. But I'm still going to show you how to import your Excel back here. Then we can now stick to the SPSS that I sent to you. And I was saying that, so let's do that. Well, before that, I was telling you the various windows and the rest. So how do you do that? You go to File, Import Data. Then the data is in what? Excel. So you click Excel. So you can realize that if you have the data in other format like CSV, test data, SAS is also another software. Stata, if you join our advanced training, we teach you Stata, Python, R, all those things into details. Today is just a webinar, so you are really touching on free basics and you'll be fine. We will teach you detail about Stata, some of the software. So there's a lot of other statistical software. But what is the baseline? The baseline is that regardless of any software that you are using, you are supposed to get the same result. You don't get different results. P-value, if you get p-value 0.1, if you use SPSS, you get the same result. R, you get the same result. GraphPad, the same result. Python, the same result. If you get a different result, it means that you handled the data wrongly in that software. But regardless of the software you are using, you get the same results. Okay. So Excel. So you get to know that SPSS is very easy to start analyzing data. But if you get to visualization, then we move to other software. So I'll click on Excel. Then you have to locate where you've kept it. So you could say that for me, because I already have opened file here, it locates me. So you have to look at or use the drop down. Then you pass through your desktop, you go to the folder that has what, where you've kept what, your Excel file. Okay, so my own, I created a folder for this training, statistics made it simple folder, and I kept this one here. So you just come and you click on it and you click open. Okay, so you use this drop down to move around your desktop explore to go to the folder that you've kept the Excel. Then you click open. Then you wait. So let's see what is coming. So this happens to any software that you are using. Even R tomorrow, you will see how to import data and in the right way. So when you get here, you don't just click OK. You have to, you see within the Excel file, there are different sheets. We have sheet 1 and clean coded. Again, I didn't specify which data you are working on. Always, we don't start even cleaning coding on your original data. Anytime you have a data, you duplicate it or you copy it to a new hot sheet. That's why within it, the sheet 1 was the original data. Then we created a new sheet within the Excel file to clean and code the data so that if you make any mistakes, you go back to the original data. But if you spend millions doing analysis, lab work, and you didn't keep the original data, then something happened, you've done error in your data analysis. You can't go back and go and do the experiment again. The same millions. So you have to always keep your original data, duplicate your data, then you now work on. So clean coded, so you select the clean coded. So that's is the sheet we've cleaned very well. So you see that it give preview of the whole stuff that you have. Then you click OK. If you click OK, it will open what? The data file for you. Then you now import. So this is how we import data to SPSS. Then all the data will be used for analysis. But if you are done, you need to recode them back. Because if you look at the one that I sent to you, if I click between, if I'm in the data view and I click between the values, so this icon on top, you see that it changes between the numbers and the labels. So how do we do that? It's very simple. We come to the variable view, okay? Then we say age group. Then under values, click on values, okay? Then what were the values we coded? We coded 1. Then what was the actual value? Was 18 to 25 years. So this is how we value it. Then we add. Then we also did 2, 26 to 30 years. That's what we did. Then 3 was. So we are now redefining the coding that we inputted. That, we are not telling SPSS to give us a specific labels so that when we are doing analysis, we can see these labels to clearly report the output. So 36 to 40. The 3 was 31 to 35. Then 4 is 36 to 45. Then okay. Age group. So you do this for all the parameters, then your data will be ready. Before that, we have to also specify the kind of variables. All these things will come. And if you happen to join our week-long trainings, you learn into details, some of the variables and how to measure them, and you are good to go. So this will make the whole data ready. So now you can just launch, if you're able to learn how to do import, just launch the SPSS that I sent to you, and let's zoom into some analysis. But before that, we will take some 5 minutes break to refresh our mind. And we now resume back because it's been more than an hour talking. Let's see what we've observed so far and how we can proceed to look at other stuffs. Okay, so we are back, and I'm happy about the progress so far. Let's see what we can now do with data in SPSS, because after we've passed through all those processes, we need to now do some analysis, and we can do that. So we are just going to run some analysis. I'm going to share my screen again. So before you can use any software effectively, you need to understand the software. So I was saying that SPSS has two windows, the inputs and the output. Okay. And if you are working with your data, you always be in the input window. Within the input window, we have the data view and the variable view. If you come to the variable view, you're able to see a lot of information about the variable, like study group, the age group that we see, the ages 7 age groups. Then within the age groups, SPSS is able to tell you about 3 different kinds of variables. It sees all numerical variables, or as we mentioned, continuous variable as a scalar quantity. So if you see a variable with this ruler symbol, it means that variable is being recognized in SPSS as what? A continuous variable or numerical variable. But if you see them with these symbols, either this or like this, they are the categorical variables. So SPSS can further specify the 2 main categorical variables, what we call the nominal categorical variable and ordinal categorical variable. What's the difference? The difference is very simple. Nominal categorical variables are those variables that come with groups, but we can't rank them. A perfect example is sex, male, female. Someone can bring male first, someone can bring female first. You cannot rank any of them ahead of anyone. But a perfect example is educational level. Educational level can be referred to as ordinal categorical variable because we move from primary to secondary to tertiary. So it's kind of a level. Or more precise, ordinal categorical variable is severity of disease, either less, moderate, severe, very severe. So those kind of variable, you could see that is have some kind of ranking. You move from a lower to a higher. So those kind of variable, we call them ordinal categorical variable. But as I said, for numerical variables, most often we see them as what? A continuous variable, so scalar quantities, and we are good to go. This some level, so for numerical categorical variables, some level make a difference. But if we move into details, so if you join more advanced training, we tell you how to effectively analyze all these kind of variables into details. The kind of analysis, why do we have to know this? It's very important because the kind of analysis we are going to do, it's depending on what? The variables that we have in the data set. The statistical software is just helping you to achieve those goals. But you have to know what is your aim, what objectives are you looking for? And the statistical software is making you do the work easy. They have all the formulas running background. That is making the work easier for you. And you use the statistical software like SPSS to achieve those goals. So for example, we sample people. Okay, let's look at some of the analysis. We sample people, then we took their baseline. So we could see that we have baseline, vitamin D. Then we further out use the WHO cutoff point to see those that have deficiency and not deficiency. So first, we can say that, oh, within the baseline, we can analyze on this whole data set. Because the whole data set from the beginning at baseline, they all fall within the particular umbrella. There's no difference. So we can do a whole analysis at baseline to see what is the prevalence of what? Vitamin D deficiency level among the 126 participants. So how do we do that? We come to analyze. Anything involving analysis, it's under analyze menu. So it makes things easier. So there's a lot of things we can do, a lot of analysis, anything you can think of. So some of these things you will never even do them till you go in retirement on your gen. So except you are doing the work that's related to a particular way before you come and do them. So we want to just do a simple descriptive. We want to see how many have vitamin D deficiency and what is the percentage. So we just come to analyze, then descriptive stats, then frequency. Analyze, descriptive stats, frequency. Then I'll click on frequencies. Then what is that variable name? It's baseline vitamin D status. You have to take note that there's two variables. One is continuous, one is categorical. It's categorical that we do descriptive analysis using frequencies and what? Percentages. So I'll move in vitamin D. Then for SPSS, you just have to make sure this display frequency table is tick. That's all. Display frequency tables is tick. Then you click OK. Then the result will come in the output window. So if you go to the output window, able to tell you that, oh, non-deficiency is 15. That's the frequency, and the percentage is 11.9%. Deficiency is 111, and the percentage is 88.1%. So you could see that this further confirms that generally a lot of populations in Ghana or Africa, Ghana, they have vitamin D deficiency. So this specifically, they are among pregnant women. So if you go and sample a lot of pregnant women, you see that they have vitamin D deficiency. It's a lot of issues that's out there. At the end, there's more research is being happening on it. Then you can report this result. But mostly, if you just report this, you cannot just do one table and say deficiency. Mostly, if you want to show prevalence, what do? We go by graph, and we can do a simple bar chart. Let's see how bar chart looks like in this graph. So to do that, I can come to graphs, legacy dialogues, then bar. Simple. We will just want simple. It's just one group defined. Then let me move in baseline. Either using the number of cases or percentages, they will all work. Then let's see what we have. Then we have this. Let me see the chart. Yes, exactly. So I was going to touch on that later on. Valid percent and percentage differs. It will differ. It will differ when there's a missing data. So I'll do analysis on the N-line vitamin D, then you're able to see that. So that's why we always focus on valid percentage, not the percentage itself. Because the valid percent will account for the missing participant. So we are going to see that when I do the analysis on the N-line. So let's see. This is the bar chart that we have from what? SPSS. But let me know, do you like this graph? If you like it, put 1 in the chat. If you don't like, put 0 in the chat. Let's see those that like this bar chart. Is it good for you to present in a work in presentable? 0, 1. If you like this bar chart, put 1. If you don't like, put 0. Do you think it's presentable enough to see your publication, to present to your supervisor, right, like that? Yes. So most of us will go for no. Yes. One, you cannot even put a lot of information because a typical bar chart, you are supposed to be able to put the number or the frequencies and percentage on top, able to modify, label the axis well to see. So you could see that what we publish. So for example, let's use some of the figures that we produce. Some of the bars. So you could see this bar chart, how we're able to show this, the number. So the 111. So the same data set we are using. So if you analyze, you're supposed to get the same result we have. The percentage frequency 111 and the percentage 88.1. 15, 11.9. Present all this nicely on the figure. And if you look at the figure, it's really hot, kind of nice. Like as soon as you see it, it's very nice. But what does SPSS give us? SPSS only produce this figure. So this is one of the disadvantage of what SPSS. So SPSS can do a lot of basic stuff, but if you come to the graphic visualization, that is why we now have to move towards the other software, like the R that you are going to do tomorrow, which will help you to do a lot of nice visualization. Present your work nicely, then to suit even publication standard. You're able to add a lot of information to it. So some of the figures you see in the publication, some of them, most of them were produced in R, some of them also be produced in GraphPad. So most often the least graphic visualization software that we teach is the GraphPad. In advance, we teach you the R, and it's nice you are going to learn R tomorrow to look at how to even do the descriptives and also some basic visualization. Yeah, so if yours come for it depends on how you coded them. So if I'm not sure you've used the data that I sent to you, but if the data that you imported, right? The data that you imported yourself right now, that you are using for an analysis, it's going to bring, for example, if you coded them is 0 or 1 and 2, it's going to bring the one first, followed by the second. If not, it will also go by. So if you didn't code it, you just imported what you work on right now, it will go by the alphabet. So deficiency D will come first, followed by N. So it's kind of followed by those kind of order. Okay, that's why you are seeing that. But this one, this data is well coded. So if you are working with the one I sent to you, you see that the non-deficiency is 0, which comes first, and the deficiency is 1. So that's why you see that result. You're good to go. Yeah. Yeah. Yes. So yeah. So you imported the Excel version. Yes. So in fact, any kind of study you are doing, okay. So it's like Ima, they're kind of objective. So we do analysis. We don't just stand up and do analysis. That's the first thing I said earlier on. The analysis, one, depends on the study design. Two, your objectives. So by the time we finish with a detailed analysis, we're able to achieve what? Any objective that you've set in your research. So maybe your first research objective is to look at the prevalence of vitamin D deficiency among the participants at baseline. Then we're able to do this analysis. This is just what? Giving you what? The frequency, telling you that yes, 101 or 88.1 have what? Vitamin D deficiency at baseline. Baseline that you've not given them the treatment. Then those that had adequate is what? 11.9%. That's the first one. Then maybe your next objective is to look at the deficiency level at the end line after treatment. It means we can now also what? Proceed and do another analysis. So your objectives will come with your data. So sometimes people will set objectives, then even the data they are taking, some of the things they want to accomplish is not in the questionnaire. It means we can't do analysis. Objectives can only be achievable through statistical analysis. So when you come to me, you want to analyze data, and I'll tell you that if you spend over 100 years doing research, spending billions, and at the end, we are not able to do proper statistical analysis to give you results, everything you've done is cost-negative. But at the end, it's the information we are seeing that is making the input. The result we are showing here, that is telling the topic. Okay, everything you are seeing here is through this. So we are saying that this improve. Why do we say vitamin D probiotics improve vitamin D and total other capacity level among pregnant women? It's through the analysis. So if you've set any objectives, anything, the only way it is achieved is what? Through analysis. So regardless of any objectives you set in your work, we're able to analyze it, your data to suit it. So Edu is achievable. So you don't have to worry if you have those variables. So let's say, what do we also look at end line? Then, so after we've seen this trend, then we randomly allocated the participant into what? Into what? Two groups. Those that took the what? So if you look at this variable groups, some people were having what? Receive. So those that received were coded 1. Those that did not receive were coded what? 0. First, then we can now, so let's see how we are going to analyze the analysis. Yes. So that's the baseline. But if you proceed to look at the overall prevalence at the end line, before we even come and do the analysis proper, let's analyze this time at the end line. So I'm going to move end line vitamin D. And let's see. So overall, you see that there's a big reduction. But this is on the whole data. Although it has moved from 88 to 83, there's reduction, but this is not how we do the analysis, because doing the analysis on the entire data again, those that did not receive is still affecting the what? The data, what we are seeing here. So what's the best way? The best way is now to do the analysis, stratifying by the study group at the end line. So in that case, we can do a number crosstab frequencies. So how do we do that? We go to analyze, discretes, and we can look at a crosstab percentage or prevalence. That is one of the ways. Or I can also show you advanced filtering, where we can filter each group and look at the prevalence like that. So we can look at the prevalence both at the baseline and also at the end line by using the crosstab. So let's do the crosstab. So this time I'm going to use the study group to the column. Then let me do both baseline and end line, and let's see what is happening. So you move them to the rows. You move the baseline and end line because we want them to come to the rows. Then the column will be our study group, the two groups of participants. Then we can come to the cells. Then we will click on column and total percentage. We want to see the percentage within them. Then continue and OK. Then let's see. First, this is the baseline. So you could see that the baseline, the two groups, at this stage, we've not given them any treatment. So the total percentage that we saw here at baseline, this 88.1, at baseline, almost the deficiency were what? Across. So you could see that deficiency with the non-treatment group were still 57, which is high, or 90%, treatment group on 85. But let's look for the end line. So at end line, there were some decrease. Then treatment group reduces to what? 75.5, whilst the non-treatment group still remain high. 99% are still having deficiency. Then we're able to report these parameters. So this is just basic prevalence we are reporting. So the baseline is, what do you want to analyze? I can show you all the tabs, analysis, any analysis you want to do. So if you want to look for frequencies and percentage, just come to analyze, okay? Discrete stars, frequencies. Then any proportion, just move in. If you want n-line proportion, just move in. Make sure frequency table is ticked. Then analyze. If you want to look at the age distribution, age group, just move in this frequencies tick. It will give you result. But what are you doing with the results? That's what will bring your objectives in. They're able to report the descriptive. So these descriptives we are seeing here, it's the first table. The first table, like, let's see, the first table, this one. So this one, the age group, you see the 18 to this, that's how we analyze them. So we just move in the age group, then we say frequency percentage. Then it gives us this table. So let me show you. So this frequency percentage, that's how we analyze them. So you could see that those, so I did error in the code, it's 18, I enter 17. But I could see that 46, but participant is 46. Then percentage 35, 30. So there's an error in the typing. I think I have to recode this well to get the actual results. 31, then 19, then we have it. So that's how we came by all those things. So I need to recode this data to get the right thing. So you come here, let's do another variable. Let's say analysis on educational level. We want to see frequencies and percentage. You come to analyze discrete frequency. Just move in educational level, okay? Then make sure this is tick, analyze. Then you have the results. So frequency, so you always report the frequencies and what the percentage. So that is if we've coded the data rightly, everything, then you'll be reporting those parameters. Let me see whether there's another question. So based on the two software, so most often the most easy software to use is SPSS. Okay, so mostly we do all the basic. So this kind of basic analysis, we do all of them in SPSS. You have to, because as soon as your data is ready, you just be analyzing this by clicking. By an R, we are going to code. So you see, at the end, I'll show you the code. So for example, this is, let me show you, in fact, let me show you the R interface. Later on, I'll still show you. So you see R, everything is coding here. So this is what we are going to see tomorrow. This is R. So everything you see here is coded. I wrote scripts, a lot of scripts to get a result. So tomorrow, George is going to, so even if you want to do basic discretes, you write code, like you'll be doing coding. But you can easily do those things in R, but those things in SPSS. But the advantage is that for you to get beautiful plots, and there's some advanced analysis, we can't do them in SPSS. That's why we move to R. So there's advantages and disadvantages in other software. But for these basic stuff, freely, we do all of them in SPSS. So depending on someone research, by the end of the data analysis, we are going to use both SPSS and R to be able to achieve the whole analysis. So from masters, PhD, always they have a lot of objectives and they have detailed objectives. So it means that you have to combine these two software to achieve the whole statistical result for the person. Okay, so I'm just illustrating some scenarios that we can do some analysis. If you want to just see like your data, you've gathered data and you want to see that what is the prevalence. Osman, a minute, then you can talk. Osmani. Or someone's hands was up. You can proceed. Let me see. Okay, then I'll go ahead with the explanation. Yes. So it depends on the analysis. So for example, if this is just a cross-sectional study, they want to see prevalence of vitamin D. That is what we just go to analyze discrete stats, frequencies. Then we move in what? Your main dependent variable. So for example, the main dependent variable is the baseline, move in frequencies. Then report. That is all. You are done with the analysis. That objective is what? Prevalence. Then you want to see what is the factors that are associated with what? The prevalence of vitamin D. Then we can proceed to do a chi-square test. So how do we do that? We go to analyze descriptive star, then we say crosstab. Crosstab. Then this time, so I don't want to bring the end line here. So that we understand some basic concept. We move in age group. Then we come to statistics. Then we take chi-square. So here we are treating the data as cross-sectional study. So then I'm moving, we are still focusing on prevalence. So this is the dependent variable that has a prevalence. And you also take out row column, then you say, okay. Then you're able to analyze that. So this is your main study group, those that have deficiency, those that do not, against age group. So this is what we call factors that are associated with prevalence of vitamin D. One of the factors can be age group. So you move in age group, then you analyze to get your result. And this is the p-value. So report this p-value, 0.574. And all this is just the baseline. You're using the baseline because at baseline, we're not giving any treatment to anyone. Okay. But if you want to also find the prevalence at end line, it means you just do the analysis, the same analysis on what? The end line vitamin D status. That is all. I don't know whether I've answered your question. Osmani, is it clear now? Yes, great. So I'm just bringing some scenarios and we use it to practice on the analysis. So anyone can bring out things. So what do you want to analyze? Bring out some objectives. So based on this data, what do you think you want to see in this analysis? Let's come up with some of those ideas, then we will analyze it. I think that will also get us involved. So someone should come up with something you want to analyze. So now this is the data we have. From your scientific perspective, what do you want to see? We have a data that we had a baseline. Then at the end, we also have two groups, okay? And we have some parameters, household, nationalities. Then we also have the diet. So what do you think you can analyze from this data? What objectives do you think you can also achieve? Yes, so now I don't want to come up with some of this. So let's come up with some of the objectives ourselves. Then we analyze on it. Yes. So the first objective that we've analyzed is the prevalence of vitamin D at baselines among the participants. And we've just analyzed it. The next objective is factors that are associated with vitamin D at baseline. So if we say factors, we are looking at, if we take vitamin D levels, what are some of the factors that will affect? So let me further touch on that into details. So the first factor that can be associated with vitamin D is age group. So to do that, we do what? A crosstab. So we go to analysis. Then we move in the vitamin D at baseline, then age group. Or maybe we want to see whether educational level is associated with prevalence of vitamin D. So we move in vitamin D to the rows, okay? Then it comes to statistics, chi-square. Why are we doing chi-square? We are doing chi-square because they are categorical against categorical. If we want to do the two group against the age group as a continuous variable, that one we don't do chi-square. We do what we call independent sample t-test. And before independent sample t-test, it is assumed that age group is a parametric continuous variable. I'll come back and explain that. But before that, let me do chi-square so that we understand chi-square. So age group against the vitamin D status. This is take, then we analyze. Then we say that, oh, educational level, does it affect it? But this p-value will tell us that, oh, it's not significant. If you have a p-value of more than 0.05, That's the alpha level. We say it's not significant. Because we have limited time, that's why I'm explaining a lot of concepts into details. But we have to also understand what is p-value. Before we can understand p-value, we have to understand 95% confidence intervals, where we are doing the analysis from. We have to understand what we call a null hypothesis. We have to understand what we call an alternate hypothesis. So there's a lot of details that we need to understand in these perspectives. Then we're able to interpret the results. Suppose we understand what we call the alpha level from the 95% confidence intervals. Then that will inform us that if we do analysis, and we have to also understand what we call the two-tail hypothesis, and we have to understand a one-tail. So there's a lot. So follow our pages, continue enjoying our webinars. Some of these things will be coming up along the way, okay? And you understand a lot of concepts. Those concepts will be coming along the way. Yes. Yes, so we can also do the association between end line and what baseline. So we are going to do that. So I'll analyze it. So that analysis will be what? Just a cross tab. So I'm going to do that. So let's do that. So this at baseline, we are seeing that age group, they are all not significant. Then let's see from baseline and end line, as someone has suggested. So let's see. So in that case, we can just do a normal chi-square. But theoretically, it is called chi-square of trend to see from baseline to end line, what did we see? So we go to descriptive stats, the same cross tab. Then this time baseline against end line. We can analyze that. Then statistics, chi-square, we want to see whether it's significant. Then okay. Then you could see that, oh, there's a little improvement of baseline and what end line. But this is not statistically what sound. The right analysis, so to modify that objectives, we want to see the association between what the treatment group and what the end line. So the treatment group and what the end line vitamin D. That should be a good hypothesis to test. So to do that, we go to analyze descriptive cross tab. Then this is we now move the end line. Then we now look at the group, the study group, to see those that received treatment, those that did not receive treatment. What was the result? So you could see that yes, vitamin D deficiency among the treatments. So you could see that there's improvement. The deficiency among the fortified group is what? Better at what? The end line. Then we're able to see that's why the p-value is what is significant. Or more specifically, to better understand it, I'm going to redo it. Now, bring this as a row, bring the treatment as a column. Then you better to see that, oh, the fortified group has a lesser or decreased vitamin D deficiency compared to what the now fortified group, that's 3%. Another one we can also analyze is that, let's see whether the dietary pattern affects the vitamin D at what, the baseline. So we can do analyze descriptive crosstab, the same crosstab. So it's very easy analyzing data when they are all categorical variable because it's only crosstab that will be doing. So let's say the dietary grade. So this is the diet. I'm moving diet grade. Then the baseline vitamin D prevalence. Then we analyze. So the same analysis column. Then we're able to see that, oh, the kind of even food that people take, whether they have adequate or inadequate, does not affect what the deficiency at what baseline. So it means that generally, if you take a population, we're taking a lot of food, but this data is showing that, oh, it doesn't really affect the vitamin D output. Then we're able to do those analysis. Yes, so we can also analyze vitamin D among what educational level. So for example, how do we do that? We come to analyze descriptive stats, crosstab. So today we are playing around a lot of categorical variables, which is nice. So baseline vitamin D, then this time educational level, just move in educational level. Then because I've already selected them, they'll be tick. Then you say, okay, then you move in, then you see that, oh, it's educational level associated vitamin D level. And you see, but this data, in your other research, you see them, some of them will be significant, depending on the kind of study you are doing. A study like that assess knowledge, you see that, oh, knowledge level will be associated with educational level. You see that most often those that have tertiary education, they'll have more knowledge about their condition. Then you're able to report. But to do that, it is through this approach. You just do a simple crosstab. Yes, you do a simple crosstab with this SPSS. Then you are good to go. Yes, so we've analyzed that. The proportion of vitamin D. So we're able to, so how do we analyze that? Analyze the proportion of participants whose vitamin D has been improved. So to do that, you can do simple analysis on the end line. So descriptive stats, frequencies. You can even do just frequencies on the end line. Then frequency, you're able to see that it has decreased. Another way I did that is we can also do what we call a PET-T test. So for example, that's why I illustrated this in the paper. A simple way is to also do a PET-T test using the two continuous variables. So let's look at this figure, this one. So this is the PET-T test. And because I don't want to just do a simple PET-T test, I'll do a PET-T test together with visualization in R. So you could see that if you take vitamin D, okay, baseline level to the end line, then you'll be able to see that, oh, there was slightly increase in vitamin D from baseline to the end line. But how do we do that? We can do what we call PET-T test. This is just to visually show it. And to do this, we can't do in SPSS. You have to go to R. So, but in SPSS, we can do what we call T-test, PET-T test. So we can come to compare means and do PET-T test. In this case, it is assumed the data is parametric, normally distributed. At this stage, I'm not able to do the normality test, but before we handle a continuous variable, we do what we call a normality test. But because of time, I'm not going to do normality test. There's different way to do normality test. We can do normality test by descriptive stats using the mean, median, mode, the skewness, the kurtosis, or we can do normality test by graphs, where we do a histogram and the normal distribution, or we can do a normality test using the Bose and Whiskers plot to see the mean, the quartiles. We can also do an analysis test using the quanta plots, the KQ plots. Some of this will look abstract, but we will do all those things before we settle that the data is normally distributed. And if it's a normally distributed, then we have the pre and post, like this data, baseline and end line. Then we can do what we call a paired sample t-test. So I'll click on paired sample t-test. Then we will move in baseline and end line. Then we analyze. It will not give you what? The t-value and the p-value. So that's how to do the analysis. So done. So today we are just learning how to use the SPSS software to analyze some data. And it's good from our ideas, we're able to do some analysis like that. The next one, yes, we've done the proportion. Yes, we can also do that. So let's say, so I'm going to touch on that and what we call a multiple variable analysis. So now let me streamline our ideas. Let me streamline our ideas to get into the ending of our webinar today. I'm going to streamline some objectives for us to work with. So I'm now moving from the longitudinal study. Let's now focus on cross-sectional studies. So we've recruited participants, okay? And now we have prevalence of vitamin D at baseline. So we are dealing with baseline. So I'm going back to do the analysis, analyze descriptive frequencies. So let's see how to own a story. So this is the prevalence, okay? Then we say prevalence. Then we want to see the factors associated with what? Vitamin D. If those factors are categorical variables, then we can say we can do analyze and text. So we go to analyze descriptives, crosstab. Then baseline. So we can move in a lot of them. Let's say age group, educational level, all of them. Even up to this, we can move in all of them and analyze together. Then we have all those analyses. This will still give you the analysis individually. So you're able to see that, right from the top, it will bring you individual analysis. So age group, you're able to see how the p-value is not significant. Educational level in this data is marginally, is almost significant, but it's not significant. Prevalence, number of previous pregnancies is also not significant. So all these are chi-square analysis. So most of your research is just chi-square. You do chi-square. This will tell you it's not significant, but you report this table and also report the p-value from the chi-square. The household, you want to see whether the number of people they have in the household is also affecting their vitamin D. So some of these studies, okay, is from your literature, you're able to bring in a lot of variables in your work. Then we're able to do the analysis to see, even the household side. Maybe if they have plenty of people in their household, they can't afford some of the needed food that will supplement vitamin D. We take all those data. Then we're able to analyze them. The number of children, do they have a lot of children? Maybe it doesn't affect like that. So all those things, nationality, does nationality affect like that? You're able to what? Do all this analysis. This is just a chi-square analysis. But at the end, if you want to move into more advanced analysis, then we have what we call logistics regression models. So logistic regression models will help us to combine a lot of these parameters together to now see how two or more affect the vitamin D deficiency. So those are the advanced analysis that we can do to assess that. Okay. Yes. So Peter, yes, we can do that. We can do associate link three or more variables to draw conclusions. And I don't want to if you want to do that, okay, let me touch on because you've asked. So to do that, you go to analyze, then we say regression models. Then we can have what we call binary logistic regression. Binary because the dependent variable is two groups. Then if you want two or more variables, you add them. In this case, we call it adjusted logistic regression models. So I will set the references. Again, this is more of a webinar. It's not a detailed training. That's why I'm not really following systematic approach. This will take time. We don't just get here. In a typical training, we focus on chi-square, then we go to a univariate logistic regression before we come to a multiple variable logistic regression. But because of the question, I'm just trying to address the question. This is how we set. So we even set references, adjust this. Then I'll go back to look at classification, confidence intervals. Then I'll analyze. Okay. Then it will take us to what we call the odd ratios confidence interval. So this is advanced analysis. This is very advanced. Advanced analysis that we do. And it depends on the focus of the work. And we can do all these things in SPSS. We can do all these things in SPSS. Yes, Peter, we can do that. But mostly, as soon as we zoom into, if you don't have the foundation, if you zoom into the advanced, you get confused. Yes, so significant. So for example, so let me go back to, so today I want to stick more into the chi-square for you to understand the chi-square analysis. So if you do a chi-square analysis or any analysis, you want to see whether it's significant or not, is we use the Pearson's chi-square. This thing, we can even calculate it manually, but software is making things simple for us. So for example, nationality against vitamin D status, right? We want to see whether it's significant or not. It depends on the p-value. Today's section is more of using the software to achieve, but before we use the software, there's a lot of concepts before we get here. Okay. So sorry if you are lucky behind, there's some concept you don't get, but if having to do more detailed training will take you from all those concepts to this stage. So I'm going to be touching on where questions come from to better address people's concern. So this is p-value. What is p-value? P-value is just a hypothesis testing. And p-value means probability value. Probability fall between 0 and 1. And anytime you do analysis, you get a value between 0 and 1. But when do we say we are accepting the alternate hypothesis or we fail to reject the null hypothesis? All these terms comes from somewhere. It should not just pop up. But the baseline is that between 0 and 1, we want to accept a cutoff point. So in this analysis, it's being done on what we call a 95% confidence intervals. So in every analysis, we want to be 95% confident that the null hypothesis is holding. If you don't understand the null hypothesis is just a natural hypothesis that says there's no significance. So if you do analysis and the p-value is more than 0.05, it means that there's no association. But if this p-value, okay, is less than 0.05, then we say that the null hypothesis now is too small for it to hold. So in this case, we now accept the alternate hypothesis. That will say that there's significant association between nationality and prevalence of what? Vitamin D. So that's how we determine what a p-value. And this p-value, again, is determined from what? The approach or the confidence intervals of the analysis. And in this case, we are doing the analysis on 95% confidence intervals. Okay, so I think some people are still interested in the advanced. So yes, so if you want to do, so first, let me do for individual. So if you want to do logistic regression, analyze. So again, let me just also brief those that are new. So why do we do logistic regression? Let's say we've done analysis in a chi-square. So logistic regression is an advanced analysis from chi-square. So let's say you've done analysis, right? Then we saw that nationality is associated with vitamin D deficiency. Okay. The next advanced question you ask yourself is, which of the nationality? Is it Ghanaians or non-Ghanaians? So a lot of people just do analysis and they'll end as what? Chi-square. We don't end there. We now move to what we call logistic regression model. So the logistic regression model will tell you that, oh, compared to Ghanaians, non-Ghanaians will have a particular chances. In this case, we will talk about odd. So if you're into sport betting, you see the odds, and you see that, oh, 2 odds, 3 odds. The odds is just the number of times you have the increased likelihood of what having the conditions. In betting, they multiply by their money. So after we've done chi-square, then we proceed to do advanced analysis like Ghanaian. Then it will tell you that, oh, being a Ghanaian has this odds increased chances of what? Having vitamin D deficiency. So to do that, you go to analyze regression binary. This is just to touch on this, but in R, we are not going to do this. Tomorrow's, we are just going to focus on how to use the R to do basic thing, the coding to understand it. That's all what we are going to do. This is just to address the question. So first, you don't do the analysis together. If you do together, you are doing adjustments. So you just put only H. So if it's only one variable, moving variable, then you come to categorical. Then you set. So in age group, you've read literature, or let me use education. So that you've read literature, then you saw that, oh, those that have higher education, they have higher knowledge of having the vitamin D, or those that have higher education level, they have decreased likelihood of what? Vitamin D deficiency. So in this case, you want to compare those that have lesser age to those that have higher age. And realize that in coding, we coded from primary to secondary to tertiary. So in this case, we want to set the tertiary as the reference. To set them as the reference, you use the last. So you click on the last, then change. So the last will become the reference. Then you get the odd ratio for what? The first three groups. So that's how we set the reference. Then continue, then options, you click classification and continue, and okay. Then you have the result. Then you're able to report that, oh, compared to tertiary, those that have, for example, here, I think it's secondary, or is it, yes, they have about 1.22 odd increased chances of having what? Vitamin D deficiency. And scientifically, you can explain that because they have less knowledge about this. That's why you do your discussion of your week. So to get a good result, it means that at least you are doing chi-square to logistic regression in a week. So that's how we set the reference to the one that asks. Those that is first time, it's good. It's always first time for everything, but that is just some case studies for today, how we use what the SPSS for some baseline analysis. Anything that you can think of, I can go ahead and talk the whole day. Any analysis I can think of, I can show you how it is done in SPSS. And but you'll be more confused as we move on into more complex stuffs. Let me know if you have more questions. If If not, I'll take this opportunity to take more questions. If not, we should end in the next 11 minutes. I don't want to take much of your time. Yes. So I'll do summary of some of the stuff we've done in 5 minutes. Then I'll still take some questions to them. So today, what we've covered is we are talking about data analysis should be simple. And how should data analysis should be simple is the statistical software. And one of the software that is very simple is the SPSS. Again, SPSS, because why is it simple? It's just click, 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 and you are doing analysis. Anything you want to analyze is come to analyze. If you want frequencies, come to frequencies. If you want to see how many people are in this age group, just move in age group. If you want to see the baseline, how many have vitamin D, you just click on it. Then you have the analysis. So apart from knowing all these tabs, the rest depends on the objectives, okay? The objectives, your study design now inform how we click this and present the work. So we've tried to analyze some of the data by looking at the prevalence of vitamin D at baseline or prevalence at end line. So we are just trying to look at, although we didn't dive more into the science basis, how to use the software to this basic understanding. But one disadvantage you realize is that the SPSS is not able to give us high quality graphs. So tomorrow's section, R was just going to visualize some of the bar chart and those things to tell you that yes, to get a better things, these are some of the stuff that you can do. Again, like this chi-square that we've done, you're able to replicate them in R. But the challenge is that we need to code those things to get the results. So being able to know which software can do your work very easily is what will make your statistics to be easy. And we've seen that SPSS is one of the basic stuffs that will make your work easy. As soon as you get your data here, everything comes to analyze, then you'll be able to analyze easily. But there's a lot of very, very advanced analysis, like when we are handling genomic data. So currently, my work is more focused on genomic. You want to do bulk RNA-seq, single cell RNA-seq, all those things. Then we now move into what the R to handle those kind of data. There's some analysis that we need to do, complex analysis. Then we now move more into what the R software, and your work will be more easier. Yesterday, someone tested me about meta-analysis. I told the person, for example, if you want to do meta-analysis, those that do systematic review and meta-analysis, we can't do meta-analysis in what? SPSS. I do meta-analysis in R. It means we now to move toward R. But a lot of people also do meta-analysis in Ripman, the Stata, those things. So that's what we do, the kind of software we have, then we're able to look at what we can analyze. Yes, let me see whether we have more questions. I'm going to stop sharing my screen so that we interact a bit how we can make your life better for you. We have to continue to share insights and grow. But we encourage you to follow our pages, recommend us to your audience. Don't miss out on any of our trainings. So let's see if I have more questions, anything, I'll try to take them at this stage. If not, I'll let Godfred or George, if you're with me, can come in, anything. Or anyone, this is open floor, last minute. Yes. Yes, I'm happy a lot. Yes, you guys, we've all learned a lot at this stage. Yes, great. Very happy, yes. Yes, so Peter, good. You're getting a lot of understanding. Edu, great. Along, yes. Damaris, yes. So things are very easy, and let's keep joining us. We have a lot of impactful sessions. I will keep running and you'll be good. No, we currently don't have, I don't have recommended way. Online transform, that's going to give you a lot of information that we have for you. So most of it, we try to recommend that you join our trainings to see what is happening. And we keep this just a tips that I've given you. We try to go into more to better understand what we do. Yes. Yes, we will share the recordings. Godfred, I don't know whether you have any further. This is like everyone is happy. Yes. How do you get in touch with expert? You can email us. You can email us. If you have any challenge, you have a big project you want to collaborate with us, we are available. So day in, day out, what I do is that I handle data. For this week, for example, one master's student is on my neck. She wants to graduate. I'm handling their data. So one good thing is that they there because we handle a lot of data that give us some of able to handle a lot of stuff that you do. So if you are a big research institution, you want people to handle your data, you are available. We do good jobs. So look at the publication we just pulled out today. Is one of the publications we always publish in high impact journal like Nature, and because of what? The statistics. Because if you do any analysis, any research, the statistics is going to give impact to the work. Okay. Then they were able to, as soon as you submit, they see that yes, whatever you've done, uh, you are going to it's worth it to publish. Yeah, you want to study, yeah, study abroad. Yeah, if you want to pursue your graduate education abroad, it's very important you pursue those dreams. But we, along the year, we are going to organize such sessions too, how to study abroad, graduate schools. But our main focus is try to impart your knowledge to make you competitive. Yesterday, my PI was teaching me how to do quantitative analysis for my Western blot in May. He just mentioned this, then he said, hey, Ben, you do theta, you do this. So imagine you get here, you don't know theta, you don't know this. They are not going back to teach you. So a lot of this, so if you know all these things, you get here, you will become top notch. Yes, yes. Next week, I'm going to some of my co-labs to go and teach them how to use R and the rest, and I'm happy to go and do that. Yes, so it gives you a lot of advantage. So we are preparing you to be competitive wherever you go to. In your workplace, you come to graduate school, you survive. Some of these things, you know them already. Yes, very happy about that. Yeah, good. Okay. Yes, and any, yeah, go for it.
Hello,
Yes.
Ebenezer, please can you hear me?
Yes, I can hear you.
All right, all right. I think right now we don't have any other question. But please, if you have any question, feel free and send them in the chat box. Let me see. Before the webinar, we sent out a registration link and to get people's comments and questions for this particular webinar. And I think most of them have been answered already. The materials for this webinar will be shared after the meeting, especially the slide and the recording. That will be shared after tomorrow's webinar. And I think some individuals were asking about research opportunities, especially for the medical students on the call, the level 100s and the level 300s. I think we are trying to get a mentorship program on board in almost all the medical schools. I think UG Medical School, they've already rolled out one that we will pay lectures with our students, right? So it doesn't matter whether you're in level 100, whether you're in level 200, or even you're in your final year. The only thing needed is your passion and your interest in the research projects being run by the lecturer. If you're interested, you can speak to your local officer, and your local officer will pay you the lecture. Yeah, we're still working on this, and we're very hopeful that by the end of this months that will be sorted out. And also, we know that for research, for every Federation of Ghana Medical Students Association, we have research exchanges on board that we allow medical students to go outside to countries like Finland, Czech. This year I have people going to Finland, Czech, Brazil, Portugal, and so many other countries. But sometimes the slots is not enough. So we are planning on having an in-country research exchange program as well. So if you're, let's say you're in K University and a particular lecturer has run a research in UDS and you're interested, when that opportunity comes, you can just speak to your local officer. He will pair you after the lecture in UDS, and then you just take it from there. And you're also speaking to various research facilities in the country, like Noguchi, KCCR, Kintampo Research Facility, and almost all the prominent research facilities in the country to allow our medical students to benefit. And it's not always that you have to finish medical school before you engage in some of these research opportunities, right? You can do that alongside with medical school so that at least after a 6 years, you know that, oh, it's not just medicine, right? At least I was able to build myself professionally and personally. So those are some of the things we are doing to make sure that our students get the research opportunities. And this is another fantastic opportunity. So Ebenezer, I can't thank you enough. Actually, when I made contact, I was thinking that it's going to be quite difficult because the time frame was very short. But then, despite your schedule and your time and all that, to be able to make time for this particular meeting, I can't thank you enough. So if there's no other question, I'll give the vote of thanks, and tomorrow you continue with R. I think whilst Seben was presenting, he made reference to most of the descriptive analysis that they are best if it's been done with R. Personally, earlier this year I attended a conference where our guest speaker, the one who will be taking us through tomorrow, Sir George, he actually taught us R, and I was amazed in some of the things that R could be used for, from our normal data analysis to like advanced genomic analysis and all that. So I'll entreat all of us to make time for tomorrow's webinar as well. We're starting exactly 3 p.m. and to be ending hopefully at 5 p.m. Today we face a bit of a challenge with the meeting, and we will make sure that doesn't repeat itself. This happens to make sure that we're able to record the meeting so that individuals who couldn't follow through or couldn't even join can have access to this wonderful presentation by, say, Eben. So if there is no other question, I'd like to give the vote of thanks, and then we'll close the meeting. Say, Eben, please, do you have any other thing to add?
No, I think you've said it all. And as you said, you being a medical student does not mean you are far away from research. Research is very important. And I do work with a lot of medical doctors from especially Confanochi doctors, because I was in K University, Dr. EC, Dr. Nimel, all of them. because if practicing and you want to be in a consulting room for 10 years, you can't stay there. You need the papers to advance. All the lecturers teaching you in all the universities across Ghana, they are doing publication that keep them moving. So that one, you cannot stay in there and you say you won't do the research. So it's very important. And thank you all. And if anytime you need any assistance, you can reach out. Thank you for joining today.
Ben. So on behalf of the organization team from FGMSA and Allied Research and Data Science Institute, I would like to express our heartfelt appreciation to each and every one of you who made today's SPSS data analysis webinar a success. First and foremost, a sincere thanks to you, our facilitator, Mr. Ebenezer Senu, for this engaging and practical and insightful presentation. The ability to simplify complex statistical concepts and make data analysis accessible and enjoyable is truly commendable. You have empowered us with tools that will not only enhance our research work, but also shape how we approach evidence-based and decision-making in our research journey. To all our participants, your enthusiasm, your questions, and presence made this session interactive and meaningful. Thank you for making the time to invest in your personal and professional development. A big thank you to the support and technical team working behind the scene, especially my general secretary, Fabiola. I don't know if she's on the call. She did a very wonderful job with the registration link and sending emails to almost all the participants. My publicity team leader, Gloria, thank you so much for the publicity. As we wrap up, we encourage everyone to continue practicing with the resource shared and to stay connected for future webinars and training opportunities. Once again, thank you for being here and keep exploring, keep analyzing, and keep making data-driven impactful. Thank you so much. Please, can we have somebody pray for the closure of the meeting?